Hello everybody. Today I am going to discuss probability distribution, which is very useful for your tomorrow's exam. You will get at least one question from today's discussion. It is also useful for UGC and Indian Economic Service exam. So let's start. I start with binomial distribution. Almost all of you would have heard about it. So a binomial experiment is an experiment consisting of a fixed number of independent Bernoulli trials. Means here the word is independent Bernoulli trials, and the fixed number means the number is fixed. So the number of trials n is fixed and all the trials are independent, which means they, if it is picking up, means they are with replacement. So there are only two outcomes in a binomial trial, and P is the probability of success and Q is obviously 1 minus P, the probability of failure. So the binomial distribution of getting probability of exactly x times in n trials. So the question will be exactly x times, means exactly 5 times, exactly 6 times out of a trial of say 10 or 15 or 20. So here the word exactly, this part, and n are fixed. So that is given by Px, x which is the probability of getting exactly x successes is fixed. So Px is equal to, formula is n choose x, p to the power x and q to the power n minus x. So you just have to identify if the question is binomial distribution or not. And how will you identify? There will be words like exactly x times or x successes, only x successes, or just x successes. The examiners try to confuse you by giving different words for the same question. So what are the properties of binomial distribution which makes it a binomial distribution? The conditions are that the number of observations n is fixed, means n is not infinity. Then second condition is that each observation is independent, means the trials are with replacement, in other words, or their probability is constant. Then each observation represents one of two outcomes, success or failure. And the fourth probability is that the probability of success P is the same, means constant for each outcome, which means that the trials are with replacement. So there are other distributions which are without replacement. So I will talk about them later on, but in this course only, in this session only. So let's go with example. So here the example is coin is tossed 4 times, means n is 4 times, and you all know that the coin tossing is an independent event with probability fixed at half. So here n is 4 times. Now what is the probability of obtaining at least 3 tails? So at least 3 tails means 3 tails and 4 tails, because there are only 4 times. So the maximum it can be 4 tails, or minimum it has to be 3 tails. So that's why I calculated probability of obtaining exactly 3 tails plus probability of obtaining exactly 4 tails. So here probability of exactly 3 tails is 4 choose 3 times p, which is 0.5, to the power x, which is 3, and q is also 0.5, means 1 minus 0.5, and to the power n 4 minus x, which is 3. So 4 minus 3 is equal to 1. So I didn't write it. So that's why that is the probability of getting exactly 3 tails. Then the probability of getting exactly 4 tails will be the same, 4 choose 4, and since probability of head is 0, So I didn't write that since 0.5 to the power 0 is 1. So I wrote probability of tail and how many times? 4 times. So that's why I wrote here 4. And the sum of this one is 0.25 and this one is 0.0625. So sum of both is equal to 0.3125. Now I go to the next question, and so that you are able to master this topic, this distribution, and it asks what is the probability of getting exactly 3 heads. So earlier I had discussed here 3 tails and 3 heads. So it will be the same because we have this fixed number of trials, n is fixed at 4 and probability of both head and tail is equal. So that's why it will be the same, but let's discuss the formula. So it is 4 choose 3. The probability of getting exactly 3 heads means they can be gotten out of 4 choose 3 ways times probability of head is 0.5 to the power 3, and then the tail occurs only once, so 0.5 to the power 1, and this one is equal to 0.25, means the same information that I got here, so I didn't calculate it differently. Then I go to the next question. So here we talked about 3 heads. Now what is the probability that exactly 0 tails or 4 heads are there? It means the same thing. The probability of getting 0 tails out of 4 trials is that all 4 are heads. So the answer will be the same for both. So that's why I wrote it to contrast with one another, means even if the question is asked differently, means the probability of getting exactly 0 tails or the probability of getting exactly 4 heads or only 4 heads or 4 heads are the same. So I wrote for tails. So it is 4 choose 0 tails, x is 0. So 4 choose x is 4 choose 0 and then 0.5 to the power 0 because probability of tails is 0.5. So I wrote it 0.5 to the power 0. And then probability of heads is that, well, they will come 4 times. So I multiplied it by 0.5 to the power 4. And this calculation is equal to 0.0625. It is the same value whether we choose 4 choose 4 or 4 choose 0 because in both cases it is 1. The combination factor is only 1. And here it becomes heads probability, so 0.5 to the power 4 and times tails occurrence 0.5 to the power 0. So this one is basically the same, mathematically calculated. Thus binomial distribution is symmetric. Whether you get 0 tails or you get 4 heads, the probability is same. Now next question. What is the probability that no heads are there? Since 0 tails and no heads means 0 heads. So here it will actually be the same. Only thing is that this is a different question. The examiner may ask you like this, while the answer is the same for all. So probability of heads I get. So 4 choose 0, the same as I did for tails. And since probability of head is also 0.5, so 0.5 to the power 0 because x is 0 here. And then n minus x is 4, so 0.5 which is the probability of tails to the power 4. And it is the same answer. Now next question is, what is the probability of exactly 1 head? Means if there is a 1 head out of 4 trials, so there will be 3 tails. So which is the same as the probability of getting 3 tails or exactly 3 tails. Whatever the examiner may ask, it is the same. Now, so the probability of getting exactly 1 head will be the same, 4 choose, and here it will be 1 instead of 0, and 0.5 to the power 1, and 0.5 to the power of tail, which is n minus x, which is 3, and that is equal to 0.25. Now next question, what is the probability that at least 1 head is there? So at least 1 head is means 1 head, 2 head, 3 head and 4 heads. So you can either calculate it like that. means you add the probability of exactly one head plus probability of exactly two heads using this same formula, and then plus probability of getting exactly three heads and probability of getting exactly four heads. Otherwise, you can do that at least one head means one minus no head. Means so this one is easier. You need to calculate only one probability of which will be of no head or zero head. So we had already calculated the probability of zero head, no head, which was 0.0625. So I deduct it from 1 because sum of probability of no head and probability of at least one head is equal to 1. So I deduct it from 1 minus 0 head probability, which is equal to 0.9375. Then we go to the mean. So since we had n is equal to 4 trials, then what is the average number of heads or what is the average number of tails that we can calculate? So the mean is np, n times p, which is equal to 4 times 0.5, which is equal to 2. So it is common sense that if we toss coin 4 times, you will notice that the average value will be that 2 times there will be head and 2 times there will be tails if the coin is fair or unbiased or balanced. Now the variance. These two questions are important because they are often asked to calculate the mean and variance. So variance is NPQ. So it is N is 4, P is 0.5 and Q is 0.5. So this one is equal to 1. So NPQ is equal to 1. A standard deviation will also be root NPQ, root of variance. So that will be 1. I hope with so many examples, you will be able to get any questions that is asked on the gate. So just look at n and x. So they will ask you, okay, what is the n? They will give you in a different word so that you get confused, but be careful in reading and you will definitely find n. And also you will find x. And that way you can use the formula and life is simple after that. So I go to example 2, which is slightly different in words. Here P is not equal to Q. So let's see the question. If from 10 to 12 during the day 1, telephone line is in every 5 is engaged in a conversation, means one telephone line in every 5 is engaged. So every 5 is here, the number of phones that gives us, so it gives us the probability. One telephone line in every 5 means 1 by 5. Out of 5 telephones, 1 is engaged. So the probability P becomes 1 by 5. Now the question is, what is the probability that when 20 telephone numbers are chosen at random? So here n becomes 20, only, exactly, or just 5 are in use. So we have the probability that the phone one will find is in use is 1 by 5. So we write it like that, B, n is equal to 20 and P is equal to 1 by 5. And obviously Q is 4 by 5. So we will follow the same steps that we did earlier, means Px is equal to n is 20, so 20 choose 5 means 5 is that of exactly 5 are in use. So this can be first 5 or means from 1 to 3, 4, 5, or it can be last 5 also, means phone number 16, 17, 18, 19, 20. So there are so many ways, or it can be in the middle like phone number 1 and then phone number 5, phone number 7, phone number 11 and phone number 12. So anyhow these 5 are chosen. So there are many ways of finding that 5 phones are engaged. So the total number of ways is 20 choose 5 and then 0.2 is the probability, so 0.2 to the power 5, which is x, and 0.8 is the probability of failure, so 0.8 times n minus x. So n minus x is 20 minus 5, which is 15, and we get 0.175. So that is our answer. Then I hope you got it very clearly since I had explained many examples in the previous page. Then what is the average number of engaged phone lines? So average is mean. So mean is NP. So 20 times 0.2 is equal to 4. So on an average, out of 20 phones, 4 will be engaged. That is what our average. And then what is the standard deviation of the binomial distribution? So standard deviation is, first we calculate variance, which is NPQ, which is equal to 3.2, and standard deviation is the square root of that. So I wrote 3.2 to the power 0.5, which is equal to 1.79. So this is the standard deviation of our binomial distribution. Now I go for example 3, and this example also has different probability. So the question will be like this. The probability of man hitting the target at a shooting range is 2 by 5. If he shoots 5 times, what is the probability that he hits the target exactly only or just 3 times? So we do the same thing. We calculate Q is 3 by 5 and P is 2 by 5. It is already given. So N is here 5. 5 choose 3 means he can hit either first, second, third, or second, third, fourth, or third, fourth, fifth, or first, third, fifth. There will be combination. And that combination is 5 choose 3 times 0.4. 2 by 5 is 0.4 to the power exactly 3 x, and Q is 0.6 to the power n minus x, which is 2. So we calculate that, and I didn't write the value here, but I can write it, but I wrote only the formula to show you. Calculation is easy with calculator. Now next question is, what is the probability that hits the target at least once? Again, it is at least once, means he hits the target in first attempt, second attempt, third attempt, fourth attempt, means 1, 2, 3, 4, exactly 1, exactly 2, exactly 3, exactly 4, exactly 5. So the easier way is deducting it. 1 minus probability of x is equal to 0. He hits 0 target. So again, I use the formula Px is equal to 5 choose 0 times 0.4 to the power 0 and 0.6 to the power 5. So it is equal to 0.075. So answer is 1 minus 0.078, which is equal to 0.92. Since he is a good shooter, he will definitely hit at least once. So the probability is very high. 0.92 is the correct probability. So I hope by now you have mastered the binomial distribution. Now I compare the other question, negative binomial distribution. So since it is negative binomial distribution, it will be very similar to binomial distribution, but there will be at least one difference, if not 5 or 10, but 1 or 2 differences will be there. So it is negative binomial, means here also we have to see that, okay, how many successes have already happened and how many trials have already happened. So we see that negative binomial distribution talks about the final success which can be obtained, means final success. Already there are some R minus 1 successes after a sequence of successes in the preceding trials. So negative binomial distribution refers to Rth success which has been preceded by n minus 1 trials, because nth trial is success and containing R minus 1 successes before. So R minus 1 success and this success becomes Rth success, and n minus 1 trials and this trial, the latest one in which there is success, that will become nth trial. So here also it is the same thing as binomial, means the number of trials is n, which is fixed, and the success is R. But it is asking that, well, third will be the success out of 5 or fourth will be success. So let me go explain it with example. So for example, 2 goals in a soccer game have been scored out of 4 attempts by a team. Then the question will be, So 4 attempts means there are n minus 1 attempts. So out of 4 attempts, 2 goals were hit and 2 attempts were wasted. Then what is the probability of scoring third goal in fifth attempt? So next time if they get opportunity, will they convert it into goal or not? That is the question. So since it takes an account of all the successes one step before the actual success event, it is referred to as a negative binomial distribution. So why is the name negative? Because it takes an account of all the successes one step before the actual success event. So that's why it is like this. It is called negative binomial distribution. So how do we solve it? So here we want to find the specific success event, which is the third, in combination with the previous needed successes. So previous needed successes were already 2 or r minus 1. And so the number of trials and the probability of success in each trial are defined clearly. Again, like binomial distribution, n is fixed, p is also fixed. So it means here also the probability means the sample is with replacement. Okay, so what is the formula of that? It is very similar to binomial distribution, means p to the power r or x or q to the power n minus r is the same that we have in binomial distribution. Only difference is that we have n minus 1 choose r minus 1. That is the only difference between binomial distribution and negative binomial distribution, but the question becomes different. Okay, so be careful of this, that whether the examiner is asking negative binomial distribution or binomial distribution. In binomial distribution, he will ask probability of n number or x number of successes out of n trials. In negative binomial distribution, there will be already n minus 1 trials and there will be r minus 1 successes, and the question asked will be what is the probability of success, rth success in n trials. Means he will ask that what is the probability of success in the next trial or in the final trial. That will be the question. Okay, now I go to the additional points of negative binomial distribution. So the mean of, we had this binomial distribution, mean was np. Here it is r times q by p. Mean of negative binomial distribution is r q divided by p, and you know q is equal to 1 minus p and r is the success. So in the binomial distribution the mean was np, but here it is rq by p and the variance is rq by p square. In binomial distribution the variance was npq. So if we see that rq by p and rq by p square, which one is bigger? Since p is small, less than 1, so here we find that the mean is always greater than the variance. That is what, then only we have this binomial distribution. Otherwise, we won't have negative binomial distribution. Now, it is also called Pascal distribution. So if the examiner puts Pascal distribution instead of negative binomial distribution, your probability, your calculation methodology will be the same. So let's go with some additional information, that what are the properties of negative binomial distribution. So the negative binomial distribution and binomial distribution, the highlighted point is the same for binomial distribution and negative binomial distribution. Means there are n number of trials. Each trial has 2 outcomes, the same as in binomial distribution, which is p and q. And then the probability of success and failure is the same across each trials, means it is with replacement. P and Q are with replacement. And then the probability of success is denoted by P. That's what I already talked about it. And so what is the difference? So let me focus on difference. The difference is the experiment is continued until R success is obtained. So long as R minus 1 successes are there, the experiment is not stopped. So here R's success is fixed. So R is defined in advance, but N is not. So the experiment consists of N repeated trials where R is the required number of successes. So N we will be given only with N minus 1 figures, not N figures, okay? So we have to add 1 to that to get the total number of trials. And we also have R minus 1 successes. So we add to that 1 to get the number of R trials. Now let's go and explain with an example so that you are better prepared for it. And here is the example. Jim is writing an exam like you with multiple choice questions, and his probability of attempting the question with the right answer is 0.6. Means he is better than average student, otherwise he would have got only 0.5. Now, what is the probability that Jim gives the third answer for the fifth attempted question? Means third correct answer actually. So, what will be the binomial question? If it is the same thing, the binomial question will be the probability of right answer is 0.6. Okay, and then what is the probability that Jim answers exactly 3 questions correctly? Here the question is, what is the probability that Jim gives the third correct answer? So far he has given only 2 correct answers out of the 5 attempts, and he will attempt the 5th question. In binomial, he will say that already there have been 5 attempts, and what is the probability that Jim answers 3 correctly. So we will see how the probability differs. So this comparison will make you understand clearly the difference between binomial and negative binomial distribution. So let's go to the solution of this. So probability of success is 0.6 and probability of failure is 0.4. Then it is given that Jim gives the third answer correctly. This is the question asked. So that's why I wrote it given. And there will be 5 attempted questions. So we have this x is equal to 5, R is equal to 3. Well, I should have written it n, not x. It is a mistake, so let me correct it n. N is equal to 5, R is equal to 3 because the third one is expected to be correct. That is the probability is asked. Not expected to be correct, but the probability of getting third correct. That is what is being asked. And P is 0.6 already given. So let me write it a small p because large P is the entire answer. And so here also I will write a small p. And we use the formula. So n minus 1 means 4. So 5 minus 1, choose 3 minus 1, that is the what has been already done. And 0.6 to the power 3, that is what is required, R is equal to 3. And Q to the power n minus R. So this is the answer, and we get the probability equal to 0.2071, or if you write it to 2 decimal places, it will be 0.21. Okay, is 0.21. Now we go to the binomial question, means answering exactly 3 questions out of 5, or he could have written, examiner can write answering 3 questions correctly out of 5. It doesn't have to be the word exactly or only, but normally a statistician write it to define it so that you can identify easily. But GATE will not do that. GATE will may write only that 3 correct answers out of 5. So in binomial distribution, we choose 5. We have this answer, no? 5 choose 3, 0.6 to the power 3, 0.4 to the power 5 minus 3. So here 5 choose 3 becomes 10. Earlier 4 choose 3 was only 6. So this one is equal to 0.3. So this one is more than 0.21. So here the only difference between binomial and negative binomial is the combination part. So I hope you understood this question correctly. Yeah, please don't forget to like my video and subscribe it. YouTube values that. Okay. That way then it gives me encouragement to answer you more or to answer more of your questions or to share more of my knowledge with you. So it is a free lunch actually. We both benefit. You get knowledge and I get some money from YouTube if my subscription is more than 1000. So please don't forget to subscribe it. I am new to this business and I am a highly qualified person, so I thought of doing or eating free lunch. Free lunch for you that you get the knowledge, and free lunch for me that I share the knowledge and I get the money. Okay, so please don't forget to like it and subscribe it. Now we go to the next example of negative binomial distribution, and it is the probability of Ron going on time to school is 80%. What is the probability that Ron goes on time for the 8th time? Means here R is 8th, yeah, and for the first 10 days of school. So N is 10 here. Now we have been given, we are using the same negative binomial distribution because it is asking goes on time for the 8th time, means already he has gone for the 7 time on times out of 9 trials. So I write the formula 9 choose 0.7 and 0.8 is the probability of going on time, and it is asking 8th time. So I wrote 8 and n minus r is 2 and we get the probability 0.41. Okay, now so yes, I already said please like and subscribe it because YouTube values it a lot. Now, so these are the two questions. I hope you learned binomial distribution and negative binomial distribution. And since I wrote them together so that you understand the difference. Okay. Next question is geometric distribution. Now, geometric distribution is a discrete probability distribution. Discrete means it is not continuous like binomial and negative binomial distribution. And that indicates the likelihood of achieving one's first success after a series of failures. In negative binomial distribution, we had series of successes, means we had at least some successes, r minus 1 successes before. Here r is 0, means there has been no success before. And what is the probability that he will get the first success? So the number of attempts in geometric distribution can go to indefinitely because he hasn't got any success. So n can be indefinite. He will keep trying until he gets first success. So n is not defined in geometric distribution, and n will be defined only when there is first success. So n is actually, it is not defined. It can go indefinitely. He will keep trying until he gets the success. So the three key assumptions of geometric distribution are that the trials are being undertaken are self-contained, and self-contained means, what does it mean self-contained? Means that is this, the trial are actually aimed at achieving the success no matter how many times, and each trial may have only one of the two outcomes, success or failure, like binomial distribution. And for each trial, the success probability represented by P is the same. It means geometric distribution is also with replacement, because P will not be the same if it is without replacement. So the sample in geometric distribution, so in all the three, negative binomial distribution, geometric distribution, and of course binomial distribution, all the samples are taken with replacement, and that's why the P is fixed, and P is fixed means Q is also fixed. So what is the formula? It is simple. 1 minus P means the probability of failure to the power x minus 1 and times P, because P is the success, so that way there will be x minus 1 failures. That is a simple formula. Now we will go with question also. So right now I am going to discuss you the geometric distribution cumulative distribution function, or one can say distribution function simply, and density function is this one. So cumulative density function means adding up to success. So success happens 1 minus p to the power x, and since total probability is 1, so up to the x success, whatever we have, we will add it, and so 1 minus p to the power x is the geometric distribution function. GATE may ask this question, or even UGC. So that's why I wrote it. And like before, what is the mean? The mean is 1 by p, and then I will go for variance also. So variance is q by p square, and the standard deviation is under root of this variance. So that becomes 1 minus p by p. Well, root 1 minus p, because this part needs to be, and p under root of p square is p. So that's why we have this standard deviation. Now we will go with examples, otherwise it won't be clear to you. So the example is, a patient is waiting for a suitable blood donor, and the probability that the selected donor will be a match is 0.25. So the blood donor will have the same blood type of the patient. Its probability to match is only 0.25. Out of 4, he gets one match. Now, what is the expected number of donors? We need to find the mean of geometric distribution. So, what is the expected number of donors who will be tested till a match is found, including the matched donor? Means matched donor is the last one which matched. So, we have P is equal to 0.25. Expectation x is equal to 1 by 5, and it becomes 4. So mean is 4. That is the expected number. So the expected number of donors will be tested till a match is found is actually 4. It was a typo error. So I make it 4. Now I go to question number 2, or example number 2, so that you understand this geometric distribution in a better manner. Here, a player is playing a game of darts. The probability of success is 0.4. What is the probability that she will hit the bull's eye on third try? So it is asking, third try she will hit, means there will be 2 failures before, and then third will be the success. So we use this geometric distribution, and the probability of success is 0.4, so probability of failure is 0.6, and since it is third try, so 3 minus 1 is equal to 2. So that is the probability of failure. 2 times fail, Q, and then last success is P. And that gives us the answer 1.44. Now I go to the next example. And the next example is about a light bulb. So a light bulb manufacturing factory finds that 3 in every 60 light bulbs are defective. So what is the probability? 3 by 60? Because 3 are defective, the probability of defective bulb is 3 by 60. So what is the probability that the first defective light bulb will be found when 6th one is selected? It means earlier 5 bulbs have been found to be non-defective, and only 6th is defective. So a series of failures. So since failure is 0.95 probability, because 1 minus 0.05 to the power 5, and times the 6th success. So that way we get the answer 0.0368. You can read it very easily. I have written it. You can stop my video and you can see the solution. Now again, why did I go for the 4th one? So this question is slightly different. So find the probability density of geometric distribution. Means it is talking about density, not a distribution. It is probability density, which is also called probability mass function. If the value of P is 0.42 and X is equal to 1, 2, 3, and calculate the mean and variance. So mean you already know. So what is the density? The density is P times Q to the power, or you could have written Q to the power first, Q to the power X minus 1 times P. Either you write it like this way, or you write it like this way. I copy this part and again paste here that what I had done, explained you earlier. So don't think that I am giving you something different. And what we do, I put this P this side and I put here P. So I come here and I write P. Okay, it became in that part. So let me write here P, and then I will put the column here, put it like this, and bring, oh sorry, let me, so this becomes P, and then I write column here, colon, and then I make, okay. So whether you write it first way or second way, the answer is means the formula is the same. Since you all are very good in mathematics, you all can easily do it, understand that there is no difference between the two. So that is the type of problem. So this is the distribution function of first part, and second part is that Px is equal to 0, otherwise means if this condition is not met, q to the power x minus 1 times p is not met, then the Px will be 0. So that's what I wrote it. I substituted the values of p and 1 minus p here because I had written like this before, but you can do it anyway. Now mean is 1 by p and variance is 1 minus p by p square. So that is what we get a variance. I hope it is clear. So you should remember this formula, mean and variance, because that can be asked in the GATE exam or in any other exam. Now last example, and then I will go to another distribution, which is the last distribution. So if the probability of breaking a pot in pool is 0.4, find the number of breaks before success and the corresponding variance and standard deviation. So standard deviation is just a square root of variance. So here the geometric distribution is about success, which is 0.4, breaking the pot, and expectation x is 1 by 0.4, which is 2.5, and variance x, and then I took the square root of this and got the standard deviation. So it was just for your information that what kind of questions can be asked in the exam. And now I go to hypergeometric distribution. So this one is different from all other distributions. Here there is no replacement. So P will keep on changing and Q will also keep on changing. So hypergeometric is different from geometric distribution, negative binomial distribution, and binomial distribution, because the trials are taken without replacement. Means the samples are taken without replacement. So that way P and Q both changes. So the selection is made from two groups, not only one group but two groups, and then I already said that it differs from the binomial distribution in lack of replacements. A simple everyday example would be the random selection of members for a team from a population of girls and boys. So the groups, one group is of girls and the other group is of boys, and they will be selected. The team will compose both. Okay, so in symbol the formula is like this. So K is K and C. Okay, let me read it. So the size of the population selected will be N, total population from both girls and groups. So that will be N with K elements of population belonging to one group. Say K is belonging to boys, and then obviously N minus K will belong to the other group called girls. So here I took K in the formula. You see probability of x is equal to a. So K is the number of boys selected, and N minus K becomes the number of girls. So out of total population, I did, and same way x will be a small n minus x. So total population of boys is K, and then obviously total population of girls will be n minus K. Yeah, and x is the number of boys chosen, and n minus x will be then the number of girls chosen. And then out of n, how much is chosen total? The small n is chosen, no, n minus x plus x. So we get the total possible choices, and we divide it by that, means that is the total number of sample events which is n choose big N choose small n. Okay, so you will understand it better with the example, but remember this formula of geometric hypergeometric distribution is not difficult. It is k is the number of one group, n minus k will be the number of other group, and x is the number of people chosen from first group. Then obviously n minus x will be the number of people chosen from the second group, and that divided by total number of choices of small n out of n. Okay, so the mean is n times k, this one, n times k by large N, and the variance is n times k times n minus. Probably this will not be asked in GATE. Otherwise, they will give you the formula. But the question can be from hypergeometric distribution because it is different from others in the sense that only this distribution is without replacement. All other distributions have replacement. So this question can also be asked in GATE that okay, which of the distribution is with replacement or without replacement, and they will give you the name. So be careful of that which distribution is with replacement and which one is without. Now here is the question of hypergeometric. A deck of cards contain 20 cards, means the total big N is 20, and 6 red cards, which is the small k. Yeah, it contains two group, no? So 6 red cards is small k, and 14 black cards, that is n minus k. So this becomes 6 plus 14 is equal to 20. Now out of k, 5 cards are drawn, means this is the small n. 5 cards means which is equal to a small n. Yeah. And the large one is, this one is equal to large N, and 6 is the number of cards, 6 red cards, which is equal to k, and 14 black cards, which is equal to n minus k. Okay, so equal to n minus k. They are done randomly without replacement. Okay, here it is written without replacement, so I make it underline for you. Without replacement. Now what is the probability that exactly 4 red cards are drawn? So you have to think it this way, exactly 4 red cards. So there are total 6 red cards, and out of that 4 red cards are drawn, means the number of possible combinations will be 6 choose 4. So that is what I wrote. 6 choose 4 is the number of 4 red cards, and then what is left? Out of 5 total, there are n small n is equal to 5, which is equal to 1 card left out of 14 black cards. So one of the cards is black because out of 5, 4 are red and 1 is black. So we have 14 choose 1 of choosing 1 card out of 14, and then divided by 20 choose 5. So that's what I wrote in the formula, and you calculate it. So 6 choose 4 is the probability of choosing 4, number of ways of choosing 4 out of 6 red cards, and 14 choose 1 is the black cards, and that divides. So this gives me the answer 0.015. Okay. Now why does binomial distribution doesn't apply here? Because here it has written exactly. So the examiner may ask you to confuse to identify, because it was the probability of choosing exactly 4 red cards. So don't get confused by the word exactly. You have to see whether it is with replacement or without replacement. If it is without replacement, binomial won't be applied. It will be hypergeometric distribution, and also there are 2 groups. In binomial there will be only 1 group. So that way this question is different from binomial distribution, and I gave the reason that the trials are not independent. Means if 4 has been chosen, then and the last one can be only 1 out of 14, or even this First is chosen and it is not replaced. Then second is chosen and both are not replaced. Then third is chosen and then fourth is chosen same way. So we have this this thing about hypergeometric distribution. Now we go for example 2. So a small voting district has 101 female voters. Let's put it K. Yeah, 101 female voters. This is equal to 101 is equal to a small K, one group female voters, and 95 are male voters. So this becomes N minus K, and total N is 196. A random sample of 10, which is equal to our small n, voters is drawn without replacement. Again, without replacement. What is the probability that exactly 7 of the voters will be female? So out of 10, exactly 7 will be female. So this one is equal to x. Yeah, small x. So of the voters will be female. So out of 101, 7 are female, times means this one, no, K choose X, and N minus K is 95, choose 3. Actually, I should have written it in superscript. I forgot to write it in superscript, so I can do it even now. And if I do it superscript, it becomes this, and 7 in subscript, then it becomes like this. So that way you will learn typing also from me on Word document. So let me convert this also, and you will be able to read it more clearly. And then C is also, though this is not required, you understand it, I know, but then I am doing it only to teach you how to write this combination in a Word document. So this 196 is the total. It becomes equal to 95 plus 101. So this becomes our 196 is the large n, and a small n is 10, which I already defined. So this becomes in the denominator, and we have this calculation as like this. So this becomes probability is equal to 0.13. Okay, here is only the explanation of that. So I hope I am clear. Please don't forget to like and subscribe. And this is what I wanted to tell you. I am sure you will get one question from this entire material tomorrow in your GATE exam. Good luck. Thank you for watching.